Now let's take a look at the non-metal. In this case, for example, it will be fluorine. So again, we look at the initial electronic configuration. It is 2.7, right? So when you draw the dot and cross for fluorine, you have 2 electrons in the first shell, and then you have 7 electrons in the second shell, right? And do take note that I've used a circle instead because it will be different from sodium where it has crosses, right? It's called dot and cross, so generally it will be a difference of circles and crosses, right? And because they are different elements, we use the different legends itself. Now, for fluorine, right, since it's the non-metal, it's going to gain the electron, right? It's going to gain an electron. And for F, right, it is in group 7, so we know it generally has a 1- charge. And because of that, we know that it gains 1 electron, because it's 1-, right? And its new electronic configuration will be 2.8. So when you draw the dot and cross for the F- ion, it will have 2 electrons in the first shell and then 8 electrons in the second shell. And do pay attention to the new electron that came in is actually a cross, because as we remember, the electron did come from the sodium ion. So we know that this electron didn't originally belong to the fluorine. So in our dot and cross, please make sure that any electrons gained actually has to be represented by a different legend. So when we put it all together, okay, if we have an ionic compound called sodium fluoride, right, you have to look at each of the individual elements and then draw their individual dot and crosses. And eventually you will get a dot and cross of the compound that will look something like this. We're just putting together the Na+ ion and the F- ion.